The question says which of the following solutions will exactly oxidize 25 ml of an acid solution of 0.1 molar iron oxalate. Okay, you can see four solutions are given there in the options having different concentration and volume. Okay, question says which solution will oxidize exactly the given salt solution. So in this case we can apply the beautiful concept that is number of molecules. Okay, if the number of molecules of any of the solution given in the options is equal to the number of molecules of the salt solution, then that solution will easily oxidize the solution of salt. Okay, will oxidize the salt solution. Let me write this statement and then based on that we can answer the question. We have the concept which we are going to apply here, number of milli-equivalence of salt solution is what? Fe, and it is C2 and O4 is there. This is iron oxalate in which iron is present in +2 oxidation numbers. Okay, is equal to number of milli-equivalence. Okay, of KMnO4. In the options whatever the solutions are given there, they are from KMnO4 only. Okay, so if the number of molecules of salt solutions are equal to the number of molecules of any of the solution, then complete oxidation reaction will be taking place. Which substance will undergo complete oxidation? You can see this salt solution will undergo complete oxidation because KMnO4 is acting as a strong oxidizing agent. Why? Because Mn is present in its highest oxidation numbers. Okay, based on the data provided we can apply the formula of number of molecules. Now pay attention very carefully. We have the formula number of molecules. Number of milli-equivalence is molarity multiplied by volume in ml and multiplied by n factor value is there. Okay, so you can see volume and molarity is given for each solution and factor value can be calculated. Okay, for this we need to write down the equation. So first of all we can calculate the number of molecules of iron oxalate. Okay, let's write down the chemical reaction. We have this is iron oxalate, FeC2O4 is there. Okay, it is undergoing oxidation in the presence of a strong oxidizing agent. Now pay attention very carefully. If I break it from here, so this is oxalate and it carries -2 charge, then iron obviously will be present in +2 charge. Anyway, it is given already Fe and this is Roman number. If iron is present in +2 charge, then this oxalate ion will have -2 charge. Okay, you can see the maximum oxidation number of iron is +3 and it is already present in +2, and since it is undergoing oxidation reaction in the presence of KMnO4, then iron will convert into Fe3+. Okay, and oxalate ion when it undergoes oxidation reaction, it converts into carbon dioxide in which carbon is present in its maximum oxidation number. Okay, now we can calculate the oxidation numbers of each element on both sides. One iron +2, second iron +3. Difference in oxidation number, you can see, if you see there is an increase in oxidation number. Increase in oxidation number is always oxidation reaction because you can see it is +2, other side iron is present in +3. Increase in oxidation number. If we find the difference in oxidation number, 3 - 2 is equal to 1 electron is there. This is what oxidation reaction. Okay, now in case of oxalate ion, we calculate the oxidation number of carbon. Always keep in mind balance always the number of atoms before balancing the charge. How many carbon? 2 carbon are there. Other side, how many carbon are there? Only 1 carbon. So I do one thing to balance the number of atoms of carbon, I multiplied by 2. Okay, calculate the oxidation number of carbon on each side. You can see 4 2 8 -2 is there, it became +6. 2 carbon is equal to +6, 1 carbon is equal to +3. Here we have +3. Okay, 1 carbon is present in +3 oxidation number. And here 2 2 4, carbon is present in +4 oxidation numbers. Okay, if 1 carbon is present in +3, then 2 carbon will be present in +6 oxidation numbers. Other side, 1 carbon is +4 and then 2 carbon will be present in +8 oxidation numbers. Now if you compare the oxidation number of carbon, left side it is +6, other side it is present in +8. You can see increase in oxidation number, +6 to +8. Increase in oxidation number is always oxidation reaction. Now find the difference in oxidation number. So you can see 8 - 6 is equal to 2 electron is there and it is also oxidation. Okay, only loss of electron is taking place. So total loss of electron, 2 electron plus 1 electron is equal to 3 electron and factor value is what? 3 we got. Okay, very interesting concept. So we got for salt solution, that is n factor value 3. That is how we calculate it. Now we can apply the formula. Molarity is given here. Molarity is 0.1. Volume is also given to 25 ml. N factor value already calculated. Now we can calculate number of milliequivalents of the salt solution. Okay, so then we have number of milliequivalents of salt solution is equal to molarity. Directly we can plug in the value 0.1 multiplied by volume in ml 25 ml multiplied by n factor value that we have calculated. It is 3 is there, so multiplied by 3. Simplify. 25 3 ja 75, 75 multiplied by 0.1, 7.5 is there. Okay, so this is the number of milliequivalents of salt solution we get. Now one by one, for the given solution in the options, we can calculate the number of milliequivalents, and the solution which has number of milliequivalents equal to the number of milliequivalents of a salt solution given in the question means that solution will only oxidize completely the salt solution. Okay, so one by one we can calculate number of milliequivalents. Now pay attention very carefully. Now let's say if I calculate for the first option is there, in this case 25 ml and 0.1 answer molar K1O4 solution is given here. Now pay attention carefully. K-amino-4 potassium permanganate is a strong oxidizing agent, powerful oxidizing agent is there, and whenever it participates in a chemical reaction, it always, especially in acidic medium, whenever it participates in a chemical reaction in acidic medium, it always converts into Mn2 plus. Okay, so you can see acid is given there oxalate. This is basically is coming from oxalic acid. Okay, so this oxalate ion we are getting from the acidic oxalic acid. It means K-amino-4 is participating in acidic medium. So therefore, when we have to calculate the n factor value for the K-amino-4, we have to convert into Mn2 plus. So let me write this equation. The equation we have the K-amino-4, we have K-amino-4, okay, is converting into Mn2 plus in acidic medium. Okay, and this equation is enough to calculate the to calculate the n factor value for the potassium permanganate. Now see, 4 to 8 potassium is what, plus 1, then manganese is present in plus 7 oxidation number. Other side you can see manganese is present in plus 2 oxidation number. There is a decrease in oxidation number, plus 7 to plus 2 decrease in oxidation number, and decrease in oxidation number is always a reduction reaction. Okay, if you find the difference in oxidation number, 7 minus 2 is equal to 5, and factor value for the K-amino-4 solution we got, that is 5. Okay, now it is very easy to calculate the number of milliequivalents. For the first option we are calculating number of milliequivalents. Number of milliequivalents, very interesting concept is there. So we have the formula molarity. How much molarity is given there? 0.1. 0.1 multiplied by volume is there, 25 ml is there, 25 ml, and then n factor value 5 is there. We simplify 25, 5 ja 125 multiplied by 0.1, it will be equal to 12.5 is there. Now we can compare the number of milliequivalents. You can see the number of milliequivalents of salt solution is 7.5, and for the K-amino-4 solution 12.5, it is not equal. So you can see oxidation, complete oxidation reaction means K1O4 this solution does not exactly oxidize the salt solution because the number of milliequivalents are not same. Okay, now we can move on to the option B. In this case 25 ml of 0.2 molar K1O4 solution is given here. For more space we can move. Okay, we can move on to the next page also, no problem. Anyway, we have 25 ml of 0.2 molar K1O4. Okay, so we have B option. In this case 25 ml of 0.2 molar K1O4 is there, K-amino-4. Okay, so you can see anyway, and factor value for the K1O4 solution will be same only because only one salt is there in each oxalate ion is given here. So n factor value in this case is also 5. Okay, now calculate the number of milliequivalents. Number of milliequivalents, we have number of equivalence will be equal to molarity is what, 0.2 multiplied by volume in ml, that is 25 ml, and then n factor value 5 is there. Simplify. 5 to the 10, 5 to the 10 we get 1.0 is there, multiplied by 25 is there, and is equal to we get a 25. So it is not matching because for the salt we are getting For the salt number of milliequivalents we are getting, that is 7.5, and in case of second solution we have 25 number of milliequivalents. It is not matching. Anyway, now we move on to the third option. In this case, third option, you can see 25 ml of 0.6 molar KMnO4 is there. Okay, anyway, 25 ml of 0.6 molar KMnO4. So we can calculate number of milliequivalents for this also. Well, we have a C option. In this case, 25 ml, volume is same of, but concentration 0.6 molar and KMnO4 solution is there. Okay, and factor value for this solution will also be same. Number of milliequivalents, okay, is equal to molarity is what is 0.6 multiplied by 25 and multiplied by, and factor value is 5 is there. Okay, 6 5 ja 30 is there, and decimal is there, we get 3 multiplied by 25 is there, and 25 3 ja we are getting 75 is there. We are not getting 7.5, keep in mind, we are getting 75 only. And in case of salt, number of milliequivalents is what, 7.5 is there, means it is not same, means complete oxidation reaction will not be taking place. Okay, then we are left with only D option. Anyway, we see the data provided in the D option. You can see we have 15 ml of 0.1 molar KMnO4 solution. Okay, we can calculate for this one also. 15 ml of 0.1 molar 1 molar KMnO4 solution. So we have D option is there, 15 ml of 0.1 molar and KMnO4 solution is there. In this case, and factor value will be same only. Number of milliequivalents is equal to molarity is what, 0.1 multiplied by volume 15 multiplied by, and factor value is 5 is there. Okay, 15 5 ja 75 is there, and 75 multiplied by 0.1 we are getting 7.5. This is what we are looking for. Okay, so you can see for the D option, the solution which is given in the D option is having the same number of milliequivalents as that of the salt solution given in the question. Okay, so number of milliequivalents, as I said in the start, the number of milliequivalents of this solution is equal to the number of milliequivalents of this salt solution. Hence, we can say option D is correct, because this solution can exactly oxidize the salt solution of iron oxalate.